Hello, my name is Matthew Robinson. I'm part of the Energy Systems Engineering program at Mohawk College, and my capstone project will be a solar tracker as well as a power monitor device that will display the current, voltage, power, and milliwatt hours. My inspiration for this project came from Steve Van Dusen. He owns and operates the company Tri-Canada Solar. He has multiple patents on solar trackers, and he has kindly showed me his system. This includes the trackers, battery banks, and the inverters. I also got a chance to co-op at two solar companies, one in high school and another one in college, so there's a lot of inspiration for solar. Of course, based on a student budget, I was limited with my resources. However, I was still able to make a small-scale working system. The components for this project include two servo motors, 3D printed parts that a friend of mine printed off from the maker from Thingiverse, four photoresistors, four 100 ohm resistors, an INA 219 for current and voltage measurement, an LCD mini screen to display the measurements, a solar panel. The one I used is a 1 to 6 volt module, an Arduino Uno to be the brains of the project, and wires to connect everything. This is the circuit diagram for the project. It's a little hard to tell where everything goes, but I'll try to explain it. From the solar panel, the positive and negative go to the V in and V in minus of the INA 219, and then from there ground and 5 volts for VCC. SATA is also connected to SATA on the LCD screen, and those both go to A4 on the Arduino Uno, and then the SCL connected to the LCD screen display SCL as well goes to analog output A5. For the servo motors, left and right motor is connected to digital 9, and then up and down vertical axis servo motor goes to digital 10. From the photoresistor and resistor side, the top left is connected to analog 0, top right analog 1, lower left analog 2, and then lower right analog 3. And then from there ground and 5 volts. The next step was the process of building everything. Starting with the code. This took up the majority of the time. There was a lot of trial and errors and a lot of hard times. But from here you can see the libraries, all the inputs. This code also allows you to take measurements with an SD card. However, I didn't have one at the time. From there we can see the movements of the servo motors. There's a lot of variations that had to be accounted for. If we keep going down, we will see all of the display for the LCD, where everything is nicely, and then from there the measurement for the INA 219. With a prototype made out of cardboard, got everything working, but then it was time to upgrade. From here I was using a breadboard, but I managed to get the 3D printed parts, and then upload the code. From there you can see it working left and right on the horizontal axis, following a flashlight. And then this shows the vertical of it going up and down. Again, using a flashlight for testing. The next step was to include the power monitor. With this you can see the voltage, the milliamps, and the milliwatt hours. In my basement apartment I don't get too much sunlight, so the measurements are very low. The final step of the project was to solder everything onto an actual board. Mind you that my soldering work could use some improvement, however it still worked in the end. Then from there it's nicely wrapped up in a box and the LCD screen is displayed on the side. One wire coming out for the Arduino Uno and then the actual tracker on top, secured tightly. So there you have it. Here's my finished project, all said and done. It was really fun to create this. I just want to thank you, Professor, for giving me this opportunity to do so. And it's really inspired me and to continue creating and making new projects and challenging myself. Thank you so much for watching, and hope you enjoyed it. That concludes my project. Here are the references I used to help me along the way, and thank you for listening.